Hi, for this lesson, I wanted to talk about an idea in geology that has perhaps an intimidating name, but actually is based on an idea that's really quite straightforward. It's a concept we call a biofacies. Now, you might remember we've used this word facies before when we're talking about sedimentary environments of deposition. So, a biofacies is where we have environments of deposition defined by the fossils that we find in them. It's based on a very simple idea. There are certain organisms that live in very specific environmental conditions. So these facies fossils, fossils that define a biofacies, are ones where we have a very specific set of environmental conditions in which they can live. And if we can work it out at present, we can work out what the environment of deposition was for rocks where we find similar fossils from the past. It's an application of an idea we call uniformitarianism, an idea crucial to geology and one we'll get into a little bit in a little bit more depth a little later in the course. Let me show you a couple of examples. Perhaps one of the best biofacies fossils are corals. Corals are very particular about where they live. They have a very specific set of environmental conditions that they can tolerate. So, for example, well, first of all, they're marine organisms. They're only found living in shallow water. 50 meters really is an absolute maximum. Usually it's less than that. That water needs to be clear, and light needs to be able to get into the water. Corals grow with a symbiotic algae that photosynthesizes. So it's got to be where light can get into the sea. Because they are attached to the seabed, they don't move around. Those conditions have to exist in that particular place for the corals to exist. We also find them in tropical and subtropical waters. They've got a very narrow temperature range of water, 23 to 29 degrees centigrade. Very pleasant, but they can only grow in that water. The water as well has to be, as we've said already, clear. Okay, so sediment free, well oxygenated, and usually as well with a current that will bring water containing the food that they filter feed across the animals. Because if coral can't go to food, food has to go to the coral. The seawater as well has to be fairly normal salinity. If we have sort of brackish water, that's not going to have enough calcium carbonate for corals to grow their skeletons. So we can see that corals live in a really quite a narrow zone. So much so that it's really defined by latitude. We're not really going to find, certainly hard corals, north of 30 degrees or south of 30 degrees away from the equator. It's very much a tropical animal. So, for example, when we find fossil corals in the rocks at Ogmore, we know that those corals didn't grow at the latitude that Ogmore is at the moment. There are no corals living in the Bristol Channel for several different reasons. Can you think what those might be? Another good indicator of environment, another good facies fossil, are plants. Pollen grains, uh, as we can see in this scanning electron microscope image here, um, give us fairly detailed records of plant communities. Now, we use this in a lot more detail in year 13 when we look at fossil pollen from the last few tens of thousands of years to reconstruct the climatic changes that happened during the last ice age. If we go further back in time, the type of plants we find, for example, in coal deposits, give us indications of, for example, tropical rainforest type environments that used to exist here in South Wales in the late Carboniferous. And it's part of our interpretation of Britain being around about the equator during that period of time. So, to summarise, the animal and plant communities that we find are very often linked very strongly to the environmental conditions that exist when those animals are alive. Where we find those in preserved in rocks, they give us a good indication of the environmental conditions that existed when those rocks were deposited. So we can define the facies, the sedimentary environment, from its fossils, from the biology that existed at that time.